Hello everyone, I am Erika Mikativo and today I am going to discuss the Greek mathematics. As you can see, we have here the subtopics, Attic and Herodianic numerals, Thales intercept theorem, three geometrical problems, and under this we're going to discuss the squaring the circle, doubling the cube, and trisecting the angle. Next we have the Zeno's paradox of Achilles and the tortoise, and the works Pythagoras and Plato. But first, we need to know what is Greek mathematics. Greek mathematics are mathematical texts and ideas from classical and Hellenistic period. But this happened from 7th century BC up to 4th century AD. Greek mathematics focused on fundamental with respect to geometry and idea of formal proof. So next, we have here a brief history of Greek mathematics. It is generally thought that Babylonian and Egyptian civilizations had influenced the younger Greek tradition. Their solutions provided the fundamental mathematical building blocks that all future mathematicians and scientists would build upon right up to the present day. So we go now to Attic or Herodianic numerals. It was the first numeral system used in ancient Greece. So Attic refers to the Greek territory of Attica, while Herodianic refers to Aelius Herodianus. So who is Aelius Herodianus? He is a grammarian of 2nd century AD who described the system in his writings. This system used only 6 symbols. Number 1 was represented by a vertical bar, just like in Roman numerals. Number 5 was represented by pi, although this numeral was often written with a short right here. Number 10 was represented by delta, 100 by eta or h, 1000 was represented by x or chi, 10,000 was represented by m called myriad. There are two ways of combining these 6 symbols into other numbers. First was that a small number atop pi represented a multiplier. For example, 500. 5 multiplied to 100. We have the h and the pi above it. The second way was to write symbols next to each other just like Roman numerals. So, di ba kapag sa Roman numerals, pinagsasama-sama lang yung mga symbols, ganun din dito sa system ng Attic or Herodianic numerals. So, the symbols were usually written in descending order, but not always. There is no standard way of writing fractions with this numeral system, as this system was typically not used for representing fractions. Attic numbers were placed by the Ionic number system between 100 BC and 50 AD. Next, we go now to Thales intercept theorem. It was established by Thales of Miletus. In mathematics, Thales used geometry to calculate the heights of pyramids and distance of ships from shore. Thales' theorem states that if a triangle is drawn within a circle with the long side as a diameter of the circle, then the opposite angle will always be a right angle. So, ganito yun. Kapag mag-drawing ka ng triangle or right triangle sa circle, ang diameter nun is always the hypotenuse kasi it is always the longest line within a triangle. So, the opposite angle of that hypotenuse is a right angle. Intercept theorem is about the ratios of the line segments that are created if two intersecting lines are intercepted by a pair of parallels. Next, we go now to 3 geometrical problems. The squaring the circle, doubling the cube, and trisecting the angle, using only a straight edge and a compass. Their actual solution had to wait until the 19th century. Hippocrates of Chios applied himself to these problems during the 5th century BCE. His contribution to the squaring the circle problem is known as the Lune of Hippocrates. His influential book, The Elements, was the first compilation of the elements of geometry, and his work was an important source for Euclid's work. First, we go to squaring the circle. It is the challenge of constructing a square with the same area as a given circle by using only a finite number of steps with compass and straight edge. The term quadrature of the circle may also refer to approximate or numerical methods for finding the area of a circle. Squaring the circle would be impossible if pi were transcendental, but it wasn't proven transcendental until 1882. The expression squaring the circle is sometimes used as a metaphor for trying to do impossible. Next, we go to doubling the cube. It is also known as the Delian problem. It is an ancient geometric problem. Given the edge of a cube, the problem requires the construction of the edge of a second cube whose volume is double that of the first. Doubling the cube is now known to be impossible using only a compass and straight edge. The non-existence of compass and straight edge solution was finally proven by Pierre Wanzel in 1837. In algebraic terms, doubling a unit cube requires the construction of a line segment of length x, where x cubed is equals to 2. Or we can simply write it as x is equals to cube root of 2. The impossibility of doubling the cube is therefore equivalent to the statement that cube root of 2 is not a constructible number. Third, we have the trisecting the angle. It is about constructing of an angle equal to 1/3 of a given arbitrary angle. On 1837, Pierre Wanzel stated that this problem was impossible. Mathematicians have been trying to solve this problem using various of methods and strategies, like for example, folding of paper or the origami and classic geometry. Next topic, we have the Zeno's paradox of Achilles and tortoise. It was attributed to the philosopher Zeno of Elea in the 5th century BCE. It was based on the infinite divisibility of space and time, and the rest of the idea that a half plus a quarter plus an eighth plus a 16 and so on to infinity will never quite equal a whole. So we have Aristotle here that doesn't believe in infinity, so he was the first of the many to try to disprove these paradoxes. Democritus was among the first to observe that a cone has 1/3 the volume of a cylinder, with the same base and height, and he is perhaps the first to have seriously considered the division of objects into an infinite number of cross-sections. Eudoxus of Cnidos. He is usually credited with the first implementation of the method of exhaustion. He used this method to calculate the volume of a pyramid and cone and was later on developed by Archimedes. He also developed a general theory of proportion, which was applicable to incommensurable or irrational magnitudes, and as well as to commensurable or rational magnitudes. From that on, the idea of proof and the deductive methods of using logical steps became an important contribution of the Greeks. The concept of proof gives mathematics its power that ensures proven theories are as true today as they were 2,000 years ago. Pythagoras of Samos. He is often called the first true mathematician, but there is no concrete evidence that Pythagoras personally solved any of the theorems ascribed to him, or it was solved by his followers. He founded the Pythagoreanism. It is a religious brotherhood located in Croton in southern Italy. In this brotherhood, they worship numbers. They believe that all is number or God is number. They consider each number has its own character and meaning. For example, we have number 1. Number 1 was the generator of all numbers. 2 represents opinion. 3 harmony. 4 justice. 5 marriage. And 6 creation. 7 represents the 7 planets or the wandering stars. and so on. But the holiest number for them was the tetrachis. They believed that odd numbers are female and even numbers are male. Pythagoreanism members were divided into two: the mathematikoi or the learners and the akosmatikoi or the listeners. The learners is more on mathematical and scientific work which Pythagoras himself began, while listeners focused on more religious and ritualistic aspects of his teachings. Pythagoras imposed his quasi-religious philosophies: strict vegetarianism, communal living, secret rites, and odd rules on all the members of his school, just like never urinating towards the sun, never marrying a woman who wears a gold jewelry, never passing an ass lying in the street, never eating or even touching black fava beans. The secrecy and the exclusiveness of the Pythagoreans results to jealousy of other members, which results to burning and destroying of their meeting places. We have here the works of Pythagoras, the Pythagorean theorem, number theory, and the music theory. We all know what is the Pythagorean theorem, right? The Pythagorean theorem states that the square of the length of the hypotenuse is equal to the sum of the square of the other two sides or the legs. So it is written as a square plus b square is equal to c square. It is not clear whether Pythagoras definitely proved it or merely described it. The simplest and most commonly quoted example of a Pythagorean triangle is one with sides 3, 4, and 5. But there are potentially infinite number of other integer Pythagorean triples. Babylonians had discovered that non-integer solutions was also possible. For example, the sides of 1, 1, and the square root of 2 has also a right angle. What Pythagoras and his followers did not realize is that this also works for any shape. Hippasus, the student of Pythagoras, pointed out the potential existence of a whole new world of numbers, the irrational numbers. When he tried to calculate the value of the square root of 2, he found that it was not possible to express it as a fraction. Later on, Hippasus was drawn by his co-members for revealing his discovery. The replacement of the idea of the divinity of the integers marked the real birth of the Greek geometry, which deals with lines and planes and angles, all of which are continuous and not discrete. We go now to number theory. It is the investigations of triangular, square, and also perfect numbers. These are numbers that are the sum of their divisor. They discovered that the square of a number n is equal to the sum of the first n odd numbers. For example, we have the square of 4 or 4 squared. 4 squared is equals to 16. And we have here the first 4 odd numbers of 16, the 1, 3, and 5, and 7. If you add these first 4 odd numbers, we have 16. Another example is 3 squared. 3 squared is equals to 9. And the first 3 odd numbers of 9 are 1, 3, and 5. If you add these 3 numbers, it will result to 9. They also discovered at least the first pair of amicable numbers, 220 and the 284. When I say amicable numbers, for example, lahat ng divisors, kapag pinag-add mo lahat ng divisors ng 220, it will result to 284. At kapag pinag-add mo lahat ng divisors ng 284, ang sum nito ay 220. We go now to music theory. Pythagoras discovered the intervals between the harmonious musical notes always have whole number ratios. He described the first 4 overtones which create the common intervals which have become the primary building block of musical harmony. So there we have the octave, perfect fifth, perfect fourth, and the major third. The mystical Pythagoras was so excited by this discovery that he became convinced that the whole universe was based on numbers and that the planets and stars moved according to mathematical equations. Last, we have Plato. He is one of the ancient Greece's most important patrons of mathematics. He was an Athenian philosopher. He founded his academy, the Platonic or the Academy in Athens. The sign above the academy entrance read, "Let no one ignorant of geometry enter here." He was convinced that the geometry was the key to unlocking the secrets of the universe. He became known as the maker of mathematicians. He demanded of his students accurate definitions, clearly stated assumptions, and logical deductive proof, and he insisted that geometric proofs be demonstrated with only a straight edge and a compass. We have here his famous work, The Platonic Solids. Plato is best known for his identification of 5 regular, symmetrical, three-dimensional shapes: the tetrahedron, the octahedron, the icosahedron, the cube, and the dodecahedron. The tetrahedron is constructed of 4 regular triangles, which each represented the fire. Next, we have the octahedron is composed of 8 triangles, representing the air. The icosahedron is composed of 20 triangles, which represents the water. The cube which is composed of 6 squares and represents the earth. And last, we have the dodecahedron. It's made up of 12 pentagons. It is described by Plato as the god used for arranging the constellation on the whole heaven. Around 1600, the German astronomer Johannes Kepler devised an ingenious system of nested Platonic solids and spheres to approximate quite well the distance of the known planets from the Sun. And last, we have here the summary. And that is all about Greek mathematics.